All right, so now that we have an idea about how to write our ions, right, we would have our positive calcium ion without any electrons. We would have our fluoride ion with 8 dots around it, 8 electrons. It's got a 1 minus charge. Now that we kind of understand how to write these ions, what we're going to do is we're going to start combining them together. So as we said, all of our bonding, ionic bonding is about the shared electrical attraction between the nucleus of one atom and the electrons of another. Okay, so what we need is multiple atoms in here. Okay, so what we can do is first off, right, what we're going to do is we're going to take our name of a compound or writing out, and we're going to write out the formula for it. Okay, so in the example up at the top, right, we're starting from magnesium fluoride. So magnesium fluoride, what we're going to start with is magnesium and fluorine that has become an ion, right? If it has "ide" at the end, then it has become an ion. So magnesium is in the second column, so it's going to go towards a 2+ charge. Fluorine, or fluoride rather, should have a 1- charge, right? So a 2+ and a 1-. For us to identify what the overall formula is, we need to essentially cancel out the charges, right? So if I take this 2 from magnesium and put it down here, and 1 from fluorine, I can put it down there, that's actually going to tell me my formula, right? So if we go down here, right, what we're going to see is that I have aluminum chloride. Aluminum is in column 13, so it's going to want to become a 3+ charge. Chloride would be chlorine as an ion. Chlorine as an ion would have a 1- charge because it is in column 17, so it wants to gain 1 electron, right? We should have that from the previous page. So now I know that I have a 3+ and a 1-. I need to take the numbers and cross and bring them down. Okay, so my formula is going to be AlCl3. I take the 1 from chlorine and I would write the 1 below, and then the 3 from aluminum and I write 3 over here. Okay, so another way for us to think about this is to think, oh, aluminum's really big and fat, and it's got a 3+ charge. But each chlorine is kind of smaller, and it only has a 1- charge. So for me to overall cancel out all of my charges, I need 3 1- charges to cancel out my 1 3+ charge. Okay, so this would be aluminum, and this would be my Cl3. So what we can see here is that I'm writing kind of a particle as a 3+, and I've got 3 1- charges, 3 separate 1- charges. These would all be chemically bonded together because there's a shared electrical attraction between the positive and the negatives. Okay? So overall, aluminum chloride is going to be AlCl3. Okay? I don't actually have to write that 1, so I'm just going to write it over here as well. AlCl3. I don't have to write that 1 because it's not needed, right? It's assumed. If we have a common subscript like Mg2O2, then we can just cancel those 2's out and write it as Mg1O1, okay? Which would just be MgO. All right, so overall, right, our ionic compounds, they have to be uncharged overall. All right, so for us to really quickly identify them, what is going to be uncharged, we can take and cross the numbers and say that aluminum is going to have 1 and chlorine is going to have a subscript of 3, right? I want to overall make my charges be balanced because normally, right, all of our compounds, they're not ionic, or they're not charged on their own, but when they are individually, we can see that we have these multiple particles in there, okay? So hopefully then we can do the rest of this worksheet.